Welcome back. Again, this is the second part. We've looked at work done and gravitational energy formula questions. Now we're going to look at kinetic energy today. Same title for the lesson because it goes over several sessions. First of all, have a go at the starter. Have a look. Pause the video. Now. And we're in pause. So here are the answers. What have we got? How do we calculate work done? We know that. Okay, we know number 2. Number 3, we're just applying again. Formula, put the numbers in, and get your answer. Number 4, once again, it's simple stuff. E equals mgh, put the numbers in. Number 5 is quite interesting because it says, what work does a light bulb do? Now remember, work is energy transferred. So what energy transfers take place in a bulb? A light bulb works to transfer electrical energy into light and heat. Okay, nice easy question. Rather a little bit more higher end sort of thinking there. Now, moving on. What is kinetic energy? The word kinetic comes from the word Greek kinesis. Have you ever heard of telekinesis? Like controlling things with your mind? Can't do it. But kinesis means to move, means motion, and so on. Okay. Anything moving will have kinetic energy. Okay. Any more key points near there? And obviously, the faster something goes, the more kinetic energy it has. Now, kinetic energy can actually be calculated using a formula, and the factors that affect it are the mass of the object and the velocity of the object. The heavier the object is, okay, the more kinetic energy, the more energy it needs to get moving. The faster an object is going, the more kinetic energy it has. And they're linked in this little formula. Kinetic energy is equal to half times mass times velocity squared. Now, I'm just going to snip to the camera because sometimes we don't like writing out the word KE. Okay, a better way of writing KE in symbol form is we would write something like this. We would write kinetic energy, EK, E for kinetic, is equal to a half mv squared. Okay, we don't need to put the multipliers in there. Now, what that actually means is we write it as a half mv squared. We could write it as 0.5 times m times v squared. Okay, but half, we just write it as a half. It looks pretty. Okay, so that's the formula written out properly. So let's just go through. We have mass is in kilograms, has to be in kilograms, not grams. Velocity is the speed, the velocity or speed measured in meters per second, and energy is in joules. We know that already. Okay. So here's an example. Car, it's got a mass, it's got a velocity. What's its energy has it got? There we go. Write down the formula, substitute numbers, calculate the answer. And one thing to note here is that we've calculated the answer to be 300,000 joules. We can write that as 300 kilojoules. Just like we have kilograms and grams, we can have kilojoules and joules. So 300,000 joules or 300 kilojoules. Kilo means 1,000. Is that easy? Good, I hope so. If you don't know, write that example down, think about it. Okay, should we move on? Yes, we shall. So we have to rearrange this equation sometimes, and it's quite a big, messy looking equation. So let's have a look. There's our equation. E equals a half mv, K E equals a half mv squared. If we want to rearrange it to find m, to find the mass, we do that. And if we want to find the velocity, we do that. Okay. And once again, I don't like using this the big KE. Let's call it EK, energy, and the little k stands for kinetic. So to write those formulas down, whoops, wrong slide, wrong thing. Let's get the camera back up. Here you go. So to write those formulas down, what's happening there? Gosh, that's gone a bit weird, hasn't it? Let's minimize it and let's plug it in. Whoops. Should we try it again? Let's flip the camera that way. Let's flip the camera that way. Hooray, that's working. Okay, let's make it big. So here's my formula. EK, kinetic energy, is equal to a half mv squared. If I want to find m, I have to bring the 2 up to here and bring the v squared below. So that would become m is equal to 2 EK divided by v squared. If I wanted to find v, it actually comes out to be that v is equal to the square root of 2 lots of the energy, is that right, divided by m. Okay, so these are our rearrangements. Now, if you want me to show you how to get to that step by step, I can do that. If not, just fast forward the video, but let's have a look. We start off with EK equals a half mv squared. I want the v on its own on this side, so I've got to get rid of this half. So if I multiply both sides by 2, I get 2ek equals 2 times a half times mv squared. What happens? That cancels out. And I want to get rid of the m, so I divide by m. So I end up with 2ek over m, whoops, dingling, equals, that 1 we don't need to write in, mv squared over what have I done there? That thing's made me go funny. That's right, mv squared over m. Does that cancel out? Yes. So we end up with v squared is that. So we square root both sides. The square root of that becomes v, and the rest of that is just the square root 2ek over m. Okay, little maths lesson. Speak to your maths teachers about it. They love that sort of thing. Okay, so let's zoom back to our slide. So these are our 3 equations. Okay. Again, example of using that. Pause that video. Pause it. Move on. 3 questions to have a go. Pause the video now. Okay. I'm coming back now. So, just refresh this to start. Okay, so we've got a 70 kilogram skydiver. What's his kinetic energy does he have? I can't remember the answer off the top of my head. Was it that one? No, it wasn't. Was it that one? No, it was that one. Yes. So write down the formula, substitute the values, do the calculation. And notice they've gone straight for 87.5 kilojoules. We could write that as 87,500 kilojoules. Okay. That's that one. Nothing challenging about that. Next one. Got a shark. It's got velocity. He's got 50 kilojoules of energy. Remember, that's 50,000 joules. Now we're trying to find the mass, so we use the formula for mass. The answer does come to be 1,000, which is about right for a shark. We write the formula, and then we substitute the numbers in, and we come up with 1,000 kilograms. Okay. Let's go next. A bullet is 8 grams. Now, and it's got this amount of energy. How fast is it moving? So we need the equation for V. Now think about this. 8 grams, we can't use that value because mass has to be in kilograms. 8 grams is 0.008 kilograms. And I happen to know that the answer is that. 350, it's about the speed of sound. So if we look here, look, we've got right our formula. Then we're substituting our numbers. Notice they put in 0.008 for the mass because it's that many kilograms. So we have to turn grams to kilograms, okay? So fairly standard. Okay, well done. Good. Now then, there are some more questions for you to do, and we'll talk about them once we've done them in class. Just review this video, make sure that you can use the formula, make sure you understand where they're coming from and so on and so forth. Okay, so that's all for now. Enjoy. See you in a bit.